value, so cos of 0, should equal 1. And if you plug that into your calculator, you will get 1. Cos of 90 is going to be 0 because the x value at 90 degrees is 0. Cos of 180, remember the x value is negative 1. So cos of 180 is negative 1. Cos of 270, my x value now is 0. Cos of 270 is 0. And cos of 360 is the same thing as cos of 0. So it's just 1. So once again, you can get these values just by using your calculator, but remember back in the day, calculators didn't exist. They had to figure out ways to do this without calculators. And yeah, this is how you do it. And finally, tan doesn't really change because tan is still y over x. It's just y over x, so how do we figure that out? Well, what's tan of 0? Well, tan of 0, what's y? Y is 0. What's x? 1. The tan of 0 is actually just 0, because 0 over 1. What's tan of 90? Well, tan of 90, x is 0 and y is 1, so it's 1 over 0. And can we divide by 0? And hopefully you've answered no, we cannot divide by 0. So this is undefined, or does not exist, or undefined. And you'll realize that whenever you have an undefined area, usually there's an asymptote there, so there's a vertical asymptote. Or I guess technically it could be a hole as well, but yeah. All right, tan of 180. And if you plug tan of 90 in your calculator, you will get an error. So that's another easy way of doing it. All right, here we have negative 1 and 0. So y is 0. 0 over negative 1, which is just 0, because 0 divided by anything is just 0. Tan of 270 is the x value is 0 again. And remember, we're dividing by 0, so it's negative 1 over 0. So once again, undefined. And tan of 360 is the same thing as tan of 0, because they are the same thing, so it's just 0. In this course, we're not going to talk about tan or the function of tan that much. We are going to use tan. I guess it's more for the next unit, so I'll talk more about it for the next unit when we're graphing. So here, when you're asked for cos of 360, how would you draw that? Well, you would draw your line at 360 like this. And then you would say, well, hey, cos of 360 is equal to x over 1, because I know it's equal to x over r, but r is 1. And here, let's take a look at the solutions here. So here we go. Sine of 270 is negative 1, cos of 360 is equal to 1. Very straightforward unit circle. And we went over the rest, so I'm going to move on to the next lesson now. What is lesson 3? Oh, okay. Lesson 3 is a good one. So this is just a review from the previous lesson. So cast rule, remember, cosine, all sine and tan are positive in their respective quadrants. Sine is equal to y over r, cos is x over r, tan is y over x. This is important. And then for a unit circle, you just change r into 1, because the radius is 1, and then you just have the exact same formulas, except r is 1. And now we're going to learn, oh, here, I'll give you this. Wait, what? I thought there were notes. Never mind. Now I'm going to teach you how to do this. Okay, so here we have an equation, sine theta equals negative 0.7. The first thing to do is grab your calculator. Where's my calculator? Oh, here it is. And all you have to do initially is to just move the sine function over. Right, theta is equal to sine -1 negative 0.7, like that. And this is not sine to the power of -1, in case anyone's wondering. That's not what that means. That's not an exponent. That's kind of to show you that it's like the inverse function. So inverse sine of negative 0.7 is what? Everyone do this in your calculator. Take out your calculators and do this right now. It's 0.7 negative, and then shift sine. And I get negative 44.4 degrees. How do I know it's in degrees? It's because A, you should be in degree mode. If you're not in degree mode, you're going to get every single question wrong. So that's the number one rule, is make sure you are in degrees mode. This is why I want everyone to actually try to do this right now. Because if you're getting a wrong answer, you might be in radians mode. And if you're in radians mode, you're just going to screw up everything. So please change your calculator into degrees mode. Or there's one more other mode. It's called radians. And you shouldn't be in that mode either. You should only be in the DEG mode or degrees mode. All right. So hopefully everyone has this value of negative 44.4 degrees. Now, hold on. Our answer has to be between 0 and 360. Is negative 44 between 0 and 360? What do you guys think? Yes or no? In the chat. What do you guys think, chat? Thumbs up, thumbs down. Is negative 44 a number between 0 and 360? All right, so only 5 people have responded. 7. Okay, people are responding now. That's good. All right, so most of you are getting it. No, it's not. So what do we do then? Because negative 44 is clearly not between 0 and 360. So what do? How can I convert negative 44 into a number that's between these values by not changing its value at all? And hopefully you remember from yesterday. You can just add 360 degrees to any angle and that will not change the angle's value. And yeah, that's all you gotta do. So what's negative 44.4 plus 360? 315.6 degrees. So that is my answer. That's how easy this is. We've solved it. But there's a key hint here. Round answers. Answers. You know what that means? That means there's actually more than one answer. And you will learn that when it comes to our periodic functions, more than likely you'll have multiple answers that satisfy this equation. And it says round to the nearest 10th of a degree, which we did. That's the 10th of a degree. So how do we figure out the second answer? Well, the first answer is 315 degrees. And I'm going to draw that out. Which quadrant is that going to be in? Well, this is 0, 90, 180, and 270. And I know that 315 is going to be in quadrant 4. I know that this is going to be 315 degrees. 315.6 degrees. What about the angle inside here? Remember to always make your triangle to the x-axis. So the angle inside, the angle that's in green, what's it going to be? Well, if I know the principal angle is 315.6 degrees, then I know that I can just do 360 minus that. You'll get 44.4 degrees. That's the angle inside the triangle, and then the main angle, the actual principal angle, is 315 degrees. What else do we know? We've learned